Have you ever wondered why we have only 10 unique numbers? Apparently it's because we have 10 fingers. I call bullshit. Then why do the 10 numbers start with a 0? And why don't we have a dedicated symbol for 10 like we do for the other numbers? We first have to understand how we represent larger numbers using just these 10 numbers. First, let's list all the 10 numbers like so. Now go to the start of the list and start counting up. To do that, we just add 1 and move down the list. But what happens if we reach the end of the list? There's certainly numbers larger than 9, so we still want to count up from 9. Something weird happens when we add 1 to 9 though. We get a 10. I know, right? What's weird is 10 is not its own number. It's made of two numbers that we already have in our list, 0 and 1. Let's see why this is. Look at the first digit, 0. Notice how we've just gone back to the start of the list and carried a 1 to the next column, and counting continues as it would normally. If we reach 19, we do the same thing, carry a 1 to the next column and go back to the start of the list. That's 20. This column tells us when we've counted past 10 numbers, so we call it our tens place. We can keep going to allow us to handle even larger numbers. That's great, but back to the original question. Why do we use the 10 number system? Well, we don't have to use 10 numbers in the original list. You can have 2, 3, 5, 10, maybe even 16 different numbers in your starting list. 10 is just the most convenient for everyday life and mental maths. But remember what we're trying to do here. We're trying to build a computer. Computers aren't boxes full of tiny wizards that connect you to the Jerkmate servers. Building a computer is like building an engine. You need tools to make the job easier. You don't just unscrew shit with your bare hands, or pull up with a slab of metal that you grind down into an engine block. In this case, the tools we need are not really tools, they're just simplifications to help with the design later on. Things that prevent dick pain, let's say. Here the first simplification is using only 2 numbers in the list to represent numbers in the computer. The binary system. Now let's try and do what we did before. Let's try and count up. 0, 1, shit. We've already run out of numbers. We can't say 2 because we don't have a 2 in the list. So we go back to the start of the list and carry a 1 to the next column. So 1 plus 1 is 10. Not really. This is 2 in binary. So 2 plus 1, that's 1, 1, which is 3 in binary. And 1, 1 plus 1 is 1, 0, 0. This is 4 in binary. See how this is what you think of as the tens place and this as the hundreds place. Now they've changed to the twos place and the fours place. See how it's ones, tens, hundreds, increasing in multiples of 10. And now it's ones, twos, fours. It's now increasing in multiples of 2. This keeps going on forever with the numbers getting increasingly large each column. Congratulations, you now know everything you'd ever need to know about binary. Literally, that's all there is to it. If you don't get it right now, don't worry, I'll provide visual aids for binary to decimal conversion in future videos. Binary numbers are really important for this series and they'll allow us to do some really cool stuff later on. Comment any criticism you have of the video and I'll improve upon it in the next video. The next video will be about tricking electricity to think. Thank you for watching. I'll see you in the next video.